Assalamualaikum warahmatullahi wabarakatuh, and a very good day to all the viewers. We are MAT123 or Calculus 1 students wanted to present about application of differentiation. Our group member is consists of 4 members. The first one will be Johan Muhammad Shazan, continue with Shafiq Haikal, Wan Ahmad Darnish, and myself, and lastly myself, Danish Roslan. At the end of the video, the viewer will be informed of these several lessons, such as first, what is differentiation? Second, application of differentiation. Third, how differentiation are used in our daily basis. Fourth, related rates, and lastly, how to solve question involving application of differentiation.
Now, moving on with the definition of differentiation. Differentiation in mathematics is the process of finding the derivative or rate of change of a function. The practical technique of differentiation can be carried out by purely algebraic manipulations using three basic derivatives, four rules of operation, and a knowledge on how to manipulate those functions. Here are the three basic derivatives. Number one is the algebraic function, which involves the derivative of x to the power of n will equal to n multiplied by x to the power of n equal to the power of n minus 1, in which n is any real number. For number two is the trigonometric function, in which the derivative of sine x would be cos, and the derivative of cos will be the negative sign. And lastly, for the basic derivatives are the exponential function, which the derivative of the constant, the exponential constant e to the power of x will be e to the power of x. For functions, the built-up of combinations of classes of functions, the theory provides the following basic rules for differentiating the sum, the product, or the quotient of any two functions, f(x) and g(x), the derivative of which are known. There are the sum and the differences, which involve the sum rule and the difference rule, the product rule, and the quotient rule. And lastly, the chain rule. The chain rule provides a way to differentiate a composite function. If f(x) and g(x) are two functions, the composite function f(g(x) is calculated for a value of x by first evaluating g(x) and then evaluating the function of f at this value of gx.
Now, if you're wondering what is application of differentiation, to solve any problems, the appropriate rate of change is determined by implicit differentiation with respect to time, as you can see in the slide, like dv per dt and dr per dt. If we consider the balloon, we can say that the rate of change in the volume v is related to the rate of change in the radius r. In this case, we can say that dv per dt and dr per dt are related rates because v is related to r.
Problem statement: water is poured into an inverted conical container of base radius 5 meter and height 15 meter at a rate of 12 meter cubic per minute. Calculate the rate at which the radius of the water surface is 2 meter. So based on this picture, this is what an inverted conical container looks like with 5 meter base radius and 15 meter height. Hint: at any time t, let the height of the water level be h and the radius of the circular surface be r. Express r in terms of h and hence express the volume v of the water in terms of h only. So from what we know, the volume formula for cone is 1 over 3 pi r squared h. From the question, the information given is dv per dt is equal to 12 meter cubic per minute. And what the question asks for is dh per dt when radius is equal to 2 meter. We can use, to get dh per dt, we can use dv per dt, which we spirit them like this. And we use dh to fill the equation. After that, using sin constant formula, we got V is equal to 1 over 3 pi hash cubic tan squared theta. Then, then to get h, we express r in term of h. And then we got h is equal to 6. Okay, next, by differentiate v, we got dv per dh which pi h squared tan squared theta, and we substitute it to the equation. So we got dv per dt is equal to pi h squared tan squared theta times with dh per dt. Then we substitute the value of dv per dt to the equation, and also the value of h and tan squared theta. And we got the answer is 0.95494 meter cubic per minute.
Alright, so this is the conclusion for our presentation. When water is poured into an inverted conical container of base radius 2 meter and height 6 meter, so the rate is 0.95493 meter cubic per minute. To get the best answer, we should list out all the information given in the question. Other than that, the right formula is also too important. In this slide, we would like to show our gratitude. We are extremely thankful that we were able to complete this assignment assigned by our lecturer, Madam Manmaharati binti Wan Abdul Aziz, within the time frame specified. This assignment will be impossible to accomplish without the extraordinary cooperation and effort of all the other group members. We also truly appreciate our lecturer for all of her willingness and assistance in the making of this assignment. Especially over the past, would like to congratulate our family members for their endorsement throughout this process.